Okay, this video is just going to go over a couple of quick things for the expected results that's required in your lab book for your individual experiment. And I'm also going to go over the transformation and ligation efficiencies. So for the table in your lab book, it's obviously, this is going to have a proper table. I just put table for lab book here, but you need a proper title. The type of information you need in your table is going to be whatever your variable is, will be one column. So plasmid, insert, strain, temperature, whatever that may be. You need to tell us the number of white colonies, the number of blue colonies, and what type of plate this was on with the concentration of antibiotic. So then you're going to have you'll have an entry for your sample of interest. If you have two samples of interest, you'll have that one, that's a maybe, your experimental control, and then each one of your technical controls, whatever that might entail for your experiment. And then I want a number in each of these, okay? And then tell us what type of plate. We're not super concerned about what the actual numbers are. We're looking for the trend. So with those numbers from your table, you are going to calculate your transformation efficiency and your ligation efficiency. So the first is the transformation efficiency. You're going to be using two plates to calculate this. The first plate, maybe more. You need a transformation efficiency. It's going to be your sample of interest, and for each sample of interest and or your experimental control. So some of you don't have experimental controls, some of you do. So you need a transformation efficiency for basically each plate that we're interested in, okay? But you're also going to need information from the LB only plate, which was the diluted TE buffer, because this represents the number of bacteria in the original culture. And obviously transformation efficiency is the number of bacteria that got transformed over the total number of bacteria. So to do the calculation, efficiency, all you do is the number of white plus the number of blue colonies on the sample of interest / experimental control plate. So once again, if you have one sample of interest and one experimental control, you're going to have two of these calculations. If you have two samples of interest, you're going to have these calculations. And if you have two samples of interest and an experimental control, you'll have three of these. The denominator of this is actually the number of colonies on the LB only plate, so this plate right here, times 10 to the 6. The reason we do that is this LB plate, before we plated it, was diluted 10 to the negative 6. So let's say there were 6 colonies on that plate. That actually represents 6 times 10 to the 6 colonies in the original culture. So we have to multiply that by 10 to the 6. So if you can see, this is very big here, and this is probably right here not going to be a very large number. It's probably going to be small. So this is going to be a small number. So don't be alarmed by that. Okay, remember transformation is very rare. Ligation efficiency, we just use the sample of interest / experimental control plate, okay? And once again, you'll have one for each one. This equals the number of white colonies, so the number that got ligated, divided by the number of white plus the number of blue, and that's all that this is on your sample of interest plate or your experimental control plate, okay? So you'll have a ligation efficiency calculation for sample of interest plate, and these numbers are coming from that sample of interest plate. And then if you have an experimental control, you'll have the same thing for experimental control. So hopefully that clears things up.